Now we're going to look at how to solve some of the more complex inequalities using something called a sign chart to determine where a function is positive and where a function is negative for the f of x values. So the first step in solving these polynomials is to find the zeros of the polynomial, and that's usually done by factoring and then setting each of the factors equal to 0 separately to solve for x. So we're looking for what x values cause the graph to have a y value of 0. What are the x-intercepts? Then we create a sign chart. A sign chart is basically just a number line, so we'll be listing out whatever values of x we're interested in, but it's a standard number line. And then once you see which x values we're interested in for the intercepts, you'll plug in a number, like you'll plug in -1 and see if you get a positive or negative answer for it. If you get a positive answer, then you would say it's positive for this section, and you go all the way until you hit the next intercept, and then you plug in another number from that region, and then again you see if plugging in numbers gives you a positive or a negative answer. So you end up with something that has a variety of plus and minus values, and that's all we're actually looking for. Where is f of x positive and where is f of x negative? So we'll determine that by plugging in x values into the function and seeing if we get positive or negative answers. So here's an example where they've actually given us the function in a factored form, which is convenient because that means we can go straight into drawing our number line. We don't have to do any of the factoring on our own. So one of the zeros is going to be caused by this factor at x equals -3. The other one is going to be caused by this factor at x equals +4. So by saying it's a 0, I'm saying that on our x and y axis, the graph touches the x-axis at -3 and +4. And so we're just interested in if the graph is above 0 on the left-hand side, in between, and on the right-hand side. We're trying to figure out where it's positive and where it's negative. So to do this, we're going to plug in a number from this far left region first. Any number that's smaller than -3 on the number line would be something like -4, -5, -6. Pick whatever number you want, and then take that number and plug it into the function we have here. If we use -4, for example, then I'll have -4 plus 3 times -4 minus 4 squared. Now you don't even have to be precise with these computations. Most of it is just going to come down to whether your answer is positive or negative. So for example, this piece right here, -4 plus 3, I know that that's going to be a negative number. Right here, I'm going to have a negative number, but then when I square it, I get a positive number. And once I multiply a negative and a positive, I'm going to end up with a negative answer. So my sign chart is going to say any number less than -3 is going to be a negative value. So now I know that on the function, it's doing something like this. To the left of -3, all of the y values are negative. And that's the same result I would have gotten if I had plugged in -4, -5, -6, -7. No matter what, I would have gotten the same result, that it's a negative. Now we want to plug in a number in between these two intercepts. So between -3 and 4, a good number I usually like to use is 0. So now I can plug in 0 for x. And again, we'll be testing to see if this answer will be positive or negative. For 0, I get a positive when I do 0 plus 3. And over here, I have 0 minus 4, which is -4. But squared is going to make it positive again. So when you multiply a positive times a positive, you end up with a positive, which means no matter what number I had plugged in this section, you will get a positive result. And in the last section here is we want to plug in a number bigger than 4. So again, you could do something crazy and plug in 100 if you want. I usually just try to stay close to the intercepts themselves. So I'm going to plug in 5. So I'm going to have 5 plus 3 times 5 minus 4 squared. And again, I'm just plugging directly into the function that they've given me to figure out positive and negative values. Well, 5 plus 3 is going to give me a positive answer. And 5 minus 4 would give me a positive answer. Squared stays positive. So in this case, when I take a positive and multiply it by a positive, the rule says the answer is positive. So what we've just determined is where this graph has negative and positive regions. If you look at the directions, they wanted to know where is it equal to 0. Well, the 0 values came from the specific x numbers, -3 and 4. Those were the two x-intercepts on the graph. The regions where the graph is positive, this happened in two different intervals. And the problem is, even though it was positive in between -3 and 4 and beyond 4, there's this one value where it's not positive at, so I can't just say all the numbers bigger than -3. I actually have to break this up and say all the numbers from -3 to +4. And then there's another set of values for this, so then it's all the numbers from 4 to infinity. That's the information we found on our sign chart here. The numbers between -3 and 4 are positive, and the numbers bigger than 4 are positive, but not 4 itself. That's why I use parentheses and not a bracket, so that I'm not including the endpoint. And then the regions where this graph is negative, that happens in one specific region. It's all the numbers less than -3. So to say all the numbers less than -3, we say going all the way down to -infinity. And that's it's going to be a negative answer until you hit -3. So the biggest value that gives you negative y values is -3, but don't include -3, so it's not a bracket. So this piece right here is our answer. We've determined where is the graph 0, where is it positive, where is it negative. They might express the question in slightly different terms, like maybe they'll just say, when is f of x greater than 0? That would mean they want to know these answers. Where is the y value positive? So make sure you understand how they can ask the question in an inequality form as well. Here's another example, but this time you'll notice that the factoring isn't completely done for us this time around. Now the 2x minus 7, I can't do anything else to that, so I'll leave that piece alone. But this second piece here, this is a trinomial, starting with x squared. So that means I can try to find two numbers that multiply together to equal +4 and add up to -4. And in this case, the numbers would both be -2, because -2 times -2 is 4, and if you add them together, you get -4. So since it's the same number twice, instead of writing x minus 2 times x minus 2, I'm just going to write x minus 2 squared. So be aware that sometimes you will need to do a little bit of factoring on your own so that you can actually find the solutions. Now we're ready to draw our number line so that we can start setting up our sign chart. There are only going to be two zeros here. One of them happens at +2, and the other one happens at +7/2. So I have 2, and then 7/2 is approximately 3.5, or it is 3.5. So sometimes you might even end up having to plug in a decimal when you're evaluating the sign chart for different numbers. But in this case, we should still be okay with just plugging in 3 itself. So again, we need to plug in numbers from each of the regions. So if I'm plugging in -1, and again, I'm just going to try to abbreviate this a little bit. Plugging in -1 is going to give you -2, minus 7 more is a negative. I'll show that I'm plugging in -1 here. And if I plug in -1 here, -1 minus 2 is -3, squared is +9. So then for this number, I'm going to get a positive. So I'm going to end up with a negative times a positive, which is negative. Now I want to plug in a number in between 2 and 3.5. So 3 is a good number to use. And if you're plugging in 3, you'll have 2 times 3 is 6, minus 7 is -1, so a negative number. And then 3 minus 2 is 1, squared stays positive. So I don't really care exactly what number it is. All I care about is whether it's going to come out positive or negative. That's why I'm just abbreviating it this way. And then a negative times a positive is negative. And then for a number bigger than 3.5, you can use 4. 4 times 2 is 8. Minus 7 is +1. And 4 minus 2 is positive. Squared stays positive. So now I know where the graph equals 0, which is at 2 and 7/2. I know where the graph is less than 0, or negative. That's in this region and this region. And I know where the graph is positive, which is for any number bigger than 7/2, or 3.5. Now, if you look back at the original question here, they were asking where is the function greater than 0? In math terms, being greater than 0 means where is the function positive? So my answer in interval notation would be to say all the values from 7/2 on to infinity. We always use parentheses for infinity, and I'm not including 7/2 as one of the positive regions because 7/2 is where the graph is actually equal to 0, not greater than 0. So if they had said greater than or equal to 0, then I would have put a bracket on this one. So that's all for your answer here. Just be careful about what kind of inequality symbol they use and whether that means you're going to be looking for the positive or negative regions. And be careful about it because if they had put the line underneath, then my answer would have been 7/2 to infinity. So you have to keep track of whether it's going to be a bracket or a parentheses in those cases. So that'll be all for the notes today. Thanks, guys.